So hey everybody, I hope you all are doing great. In this video, we are going to see a very important type of dynamic programming problem, which starts a new kind of type of problems, which is longest increasing subsequence, right? So longest increasing subsequence is of course a problem in itself, and it is a very famous problem, but it is also a prerequisite of a lot of the problems we are going to do next. So basically, longest increasing subsequence comes as a set of problems, right? And this is the core of it. In this video, we are going to see the you can say recursive memoization and tabulation technique of the non-optimal way, or you can say more generic way of solving this problem before moving to the like optimal way to solve this problem itself, right? But we have to understand this problem first, that what this problem is saying. This problem is simply saying that given an integer array nums, return the length of the longest strictly increasing subsequence. Okay, then let's go to the board itself and let's see there that what the problem is actually saying. So the problem name is longest increasing subsequence, and before seeing what is this longest increasing subsequence, let us discuss what is the subsequence first in an array, right? So we have three things, which is a subarray, we have a subsequence, we have a subset, right? So subset is the collection of, you can say, people which are present in the array. For example, 200 comma 2 is a subset of this array because all of the people in this subset are there in the array itself, right? So all of these people are present in the array. In subset, we are only concerned whether the people are there in the, you can say, whole array or not. Okay. Sub array is a you can say a contiguous part, a contiguous segment of a array, right? If I cut this chunk out of this array, this is a sub array. If I cut this much, this only this single element, this is also a sub array of this array. If I cut this much chunk out of this array, this is also a sub array, right? But I cannot say that 200 comma 2 is a sub array, because like 200 comma 2 is not there as a chunk, they are present as different elements. So in a way, I can say 3 comma 200 is a sub array of this array, right? What is a subsequence on the other hand? Subsequence is the combination of subarray and subset. It is just like, all the elements in the subsequence should be present in the array itself, but they should be present in a proper order. They should be present in a proper sequence. They can be together like contiguous or not. For example, you can say I can select this 2, I can select this 3, I can select this 7. This is forming a subsequence 2 comma 3 comma 7. This is the subsequence of this array. The elements are not necessarily continuous, but they all are present in the array and they are present in the proper order. 2 is coming first, then 3 is coming, then 7 is coming, right? I cannot say 3 comma 2 comma 7 is a subsequence. I will not say 3 comma 2 comma 7 is also a subarray. I will only say 3 comma 2 comma 7 is a subset of this array. Okay. So I hope this is clear to everybody that what is the difference between subsequence, subarray and subset. Basically, subsequence is just a, you can say, contiguous or non-contiguous part of the array, right? Which is in a proper order. So let us analyze this problem of longest decreasing subsequence and let's see what they're saying us, like telling to us. So in this problem, they are asking for longest increasing subsequence. So what is an increasing subsequence? For example, 5 and then 200. Is this an increasing subsequence? Yes, my friend, it is an increasing subsequence. Okay. Let's see. 100 comma 101. Is it an increasing subsequence? Let's consider this 2 comma 7 comma 101. Is this strictly increasing? Yes, definitely, my friend, it is strictly increasing. This means that this is a strictly increasing subsequence. Okay. All right. So I hope this is clear that what is a strictly increasing subsequence. I want the longest increasing subsequence in this array. What is the longest? Let's say I'll consider 2, then I'll consider 3, then I'll consider 7, then I'll consider 101. So 2 comma 3 comma 7 comma 101 is a longest increasing subsequence of length 4. Basically, you have to return the length of the longest increasing. You just don't have to return the whole longest increasing subsequence. You just have to return the length of the longest increasing subsequence. Basically, 4 is the answer, that the length of the longest increasing subsequence formed using all the elements in this array is 4. And yes, if you are wondering whether 2 comma 5 comma 7 comma 101 is also a longest increasing subsequence, yes, that is also one of the longest increasing subsequence. There can be multiple longest increasing subsequence, right, of equal longest lengths. But only thing we are concerned is the length of the longest increasing subsequence. This you have to return from the array itself. And I hope the problem statement is clear to everybody that what the problem is asking. Array is given, you have to tell me the length of the longest decreasing subsequence. Let us look and try to derive a recursive approach for this problem and then move forward. So this is the test case we are having. Let me write the indexing here. And these are the elements we are having in the array. We have to tell whether what is the longest length of the longest ingredient subsequence in this array. Let us try to derive some recursive kind of approach for this problem, right? For this problem, right? Okay. So what we are having here in the recursion, I will keep track of two things. One, the index I am standing on currently, and one, the index which is coming after me, right? It might be a little bit confusing, just but bear with me a little bit for a moment, right? So let me write the indexing here. Let's say there is a sixth index which is having an infinite, correct? Let us imagine there is a sixth index having infinite, correct? I will call current index as 5 and next index as 6. So what am I meaning here? So if I am on the fifth index and the next person in the longest ingredient subsequence is the sixth person after me, right? What I can make as longest ingredient subsequence, this I will try to make, right? Because in longest ingredient subsequence I have to keep a track of two things. First, everybody can come or cannot come, right? Everybody can be included or can be excluded, right? This is the first case, right? Everybody can be included or can be excluded. But I also have to keep in mind that I only include those people who are smaller than the next person, right? For example, 10 is the next person. So people before 10, like the longest series subsequence can be formed by like what all people? I can only include those people who are smaller than 10. No, I cannot like add an 11 here and I can call this a longest series subsequence, correct? So this becomes wrong, right? I have to keep a track of two things. The person, like the person I'm talking about right now, which is the IDX, the index I'm standing on, and what else? The person who is next in my longest increasing subsequence, like in my subsequence, right? Because I'm forming the longest increasing subsequence from the back. I'm forming it from the back. Let us see, like if it is not clear, don't worry. Like we are going into this algorithm itself, and once you get the hang of it, you will like understand everything, right? So I will say that 5. Either 5 can be excluded. If this fifth index can be excluded or this fifth index can be included, correct? This fifth index can be excluded or it can be included. For example, if fifth index can be excluded, this means that I am not taking into consideration this fifth index, correct? This means it will be ignored and I will ask from 4. But from fourth index, who will stay the next? 5 is not getting included, 5 is getting excluded. So sixth index will stay, the next value itself, correct? It will stay the next value itself. Again, 4 will call if it gets excluded. When 4 gets excluded, what is 4 able to do? If 4 gets excluded, it will call for 3, but this time what is the next value? What is the next value after 3? It will not be 4, my friend, because 4 is not getting included. It will stay 6 as it is. It will stay 6 as it is. I will call again. So here, let's say 3 gets excluded. I am just covering all the exclusion calls first. So third element says that what is the best I can do if I get excluded from the longest sequence subsequence. All the people before me tell me that. So it will ask index 2. But from 2, who will be the next person? 3 is getting excluded. So it will stay the sixth person. Sixth person will stay the longest sequence subsequence, right? So I think it is becoming a little bit bigger, but I don't care, right? We have to understand this thing correctly, right, in order to move forward, right? Okay, so I'll just bring them here and let's try to explore it more. So now 2 will call for 1 and next person, because second index is getting excluded. This means that the next person is 6 only. 1th index, if it does the call of exclusion, you can say 0th index, what's the best can you do if the next person is 6? 0th index is saying I am also getting excluded. If 0th index gets excluded, it will call for minus 1th index and next person will stay 6 only, right? Now this minus 1 person, yeah, there is no one here. There is no one here. What is the best can it do? Right, minus 1 always return a 0 because minus 1, it cannot make any longest increasing subsequence, so the length of longest increasing subsequence it is going to return is 0, right? I think that it is a little bit confusing right now. Don't worry, right? You will understand everything in just a moment. Once we start exploring this side of the tree, you will understand everything, I promise that. Okay, so 6 has done the exclusion call, right? This 0th index has done the exclusion call. Now it is time to include the 0th index. If 0th index gets included, It will say -1, what is the best you can do if the next person is 0? Can you see this? When we are doing an exclusion call, for example, I am standing on index. I am standing on index, and let me draw it correctly. I am standing on index, and I am basically, my next person is whatever next person is there. If I get excluded, I will call index -1 with the same next person. But if I get included, I will ask from index -1, but this time the next person, since I am getting included, I am the next person. I hope this point is pretty much clear to everybody now. So this -1 always returns 0 no matter what. So we get 0 from here, but this 0, we will add 1 to it because 0th element is getting included. No, 0th element is getting included. So what is the max of both of these two values? It will return 1. So we will return 1 from here. We will return 1 from here. So excluded, comma, whatever previous people can do if I get included, plus 1 because I am getting included, right? So this versus this we will always do. So okay, so one element is saying if 6th is the next element and I am trying to stand behind 6, like if I'm not coming behind 6, the previous people are able to do 1, right? They are able to achieve 1. If one element gets included, gets included, what is the call? We will ask from the previous index, but this time one element is getting included. This means that the next thing, the next index, instead of passing 6, I will pass myself because I am getting included. I am the person who will be coming after you. Correct? I am the person who will be going after you. Correct? I hope this is clear to everybody. Now let us keep this aside and let's try to explore this side of the tree. So 0, 1, 0, 1. So 0 will say what? If I get excluded, what is the best I can do? If 0 gets excluded, of course it will call for -1. It will call for -1, 1, right? And I will, whenever I call get -1, I get a 0. Now tell me one thing. Can I include the 0th element if the next element is 1th element? Can I include this element if 5 is the next element? Yes, because 2, 5, it is forming an increasing subsequence, right? So if my value is smaller than the person next to me, then only I will try to explore my including side. So I will try to explore my including side. Correct. And whenever there is 6, that's why I've taken infinite here, because 1 will always try to get included because of this infinite, right? So 0th element is trying to get included, right? This means that I will call for -1. I will call for -1, comma. Who is the next element? I am getting included. 0 will become the next element. And whenever the index becomes -1, I'll return 0 always. And this will return what? Maximum of excluded, comma, including +1, because I am getting included. That's why I'm doing +1 here as well. So what is the best I'll be doing? I'll be doing max of both of these two values. So here I will return 1. I hope this point is clear to everybody, right? The only thing is that it is pretty similar to pick or not pick strategy. But what we are trying to do here is we are trying to check whether, if the only thing is that the simple, if I give you the gist of the algorithm, I will try excluding every time. But I can get included only when I am smaller than the next person, and next person pointer is given to me by whoever is calling me. So 1, 6, look at this, my friend. 1, 6, if this 1th element does not get included, the best it is able to do is 1. Length of the longest increasing subsequence is 1, only this array which is having 2. If 1th element is in getting included, previous people can make a length of 1. And since I am standing, this 5 is standing after all these people, I will add 1 because it is getting included. Max of both of these values, this returns a 2. Correct. I hope this is clear to everybody. Yes or no? I hope this is clear to everybody. This +1 is by my side and this is what was returned by 0, 1. I hope it is clear to everybody. Let's explore this side. I have promised you, once you reach this side, you will understand the whole algorithm. Let us explore this side first. So we have to check whether 2, 6 second element can be included or not. Before making the including call, I will say that what is on the second index? It is 3. What is on the 6th index? It is infinite. There is actually no 6th index is having infinite. This is like I've taken arbitrary that last index I'll consider to be infinite only, right? So 2, 6. Yeah, can I be standing, like, can I get included behind this? Yes, definitely, my friend, you can get included, right? Basically, if we are checking for infinite, 3 is basically saying if I am the last person of the longest increasing subsequence. So it will call including call. So if I get included, let's see what happens. If 2,6 gets included, I can simply say that the previous person will be 1, and since I am the person who's getting included, I will simply say what? I will simply say that I am getting included, so next person is 2 only. Correct? Okay. So 1 comma 2. All right. 1 comma 2 will say what? Okay. If I get excluded, I'll be calling for what? 0 comma 2. Correct. I'll be calling for 0 comma 2. Let me draw it like this a little bit more. You can say okay, to the side, right? Okay. So what is the call I'm going to do? I'll be calling 0 comma 2. If I get excluded, if one element gets excluded, previous element is 0, but the next element will stay 2 because one element is getting excluded. Okay. Now explore this area. If 0 gets excluded, again I'll be calling for -1 comma 2. I'll return 0 from here. If 0th element can be included, can the 0th element be included? What is the second element? 2. Can 2 stay behind 3? Yes, 2 can stay behind 3. So if 2 can stay behind 3, what am I going to do? Full focus ka dekhna hai. I will simply say 0 comma. So I will what will I say? Full focus ka dekho. I'll say -1 comma. I am getting included. So -1 comma what? I'll pass, since 0th element is getting included, 0. And what is the answer for -1 comma 0? Always we return a 0. So I'll return 0 from here. Now since 0 comma 2, like 0th element is getting included, 0 versus 0 plus 1, I will return a 1 here. That is 1th element if you get excluded, and second element is the next element. 2 can stay behind. 2 can stay behind that if 1th element. You can see here what I'm trying to say, right? 1th element is saying my next element is 3, and the person before me, I am getting excluded. 1th element says I'll not come. What is the best I can do from the people behind me? They are saying we can make a 1. Okay. I hope this is clear to everybody. Let us move a little bit more further and then it will be more clear. Full focus ke sath dekho yaar. So 1th element is getting excluded. Can 1th element be included? Look at this, my friend, closely. Can 1th element get included? Look at this. 1th element is 2. 2th element is 3. Can 5? 1th element is 5. Can 5 stay behind 3? No. Increasing subsequence. So I cannot make an including call. That's why I am maintaining this next index. I hope it is clear why am I making, like, including this next index, so that I have to, of course, stop the including call as well whenever I am, not in the, you can say, valid range. If the next person is smaller than me, how can I be standing behind that person, right? So I'll not be doing any call here. I will simply return 0 from here. What is the best? 1 versus 0. You can definitely see if the next element is 3, it is best to not include 5, right? So I will return 1. All right, 1. Look at this 2,6. 2,6. Second element is saying if I get excluded, I'm able to make 2. Because of this 2,5. If I'm getting included, I'm able to make 1 plus 1, which is 2 and 3, which is 2, right? Maximum of both of these values is 2 only, so I will return 2 here, right? I hope it is clear to everybody. Now we are going to explore this tree and it will get more clear because 200 is a very good test case. Let's see. So this tree is getting a little bit, hodgepodge, but I hope it is getting clear to you all that now is the time. Third index will try to verify whether it can make an including call or not. Before making an including call, I will always check, can I make an including call according to the next index as well. You can say 3, 6, we can make an including call. So I will make an including call here. So let's make an including call here. I'll call it like this, including. So if the third element gets included, the previous element is 2, and since the third element is getting included, the next element for the previous people will be 3 only, correct? So I hope this point is clear that if I am getting excluded, right, next will go as it is. If I am getting included, this means that I'll become the next person for the previous people. So I'll pass here the next index only, right? So 2,3, and it is like clear. And now 2,3, have we already covered 2,3? No, I guess no. So let us try to cover this. So 2,3, we are standing on second index. If we are standing on second index can be excluded or it can be included, right? If second index gets excluded, right, what is the best it's able to do? It will say that I'll call for 1 and I'll pass 3 here, right? I'm getting excluded. I'll not write 2 here because I'm getting excluded. Second index is getting excluded. Again, let's explore this side. So 1 will say if I get excluded, if I get included, like I'll not say like whether we are getting included or not yet, but let's explore the excluding side. So 0th element and 3 I'll pass as it is. 0 will say if I get excluded. If 0th element gets excluded, we'll of course make a call for -1, 3. -1 always return a 0. Because there is no more element, so of course we cannot make anything. Can the 0th element get included if the next element is the 3rd element? Okay, let us look at this. So 0, 3, right? It will call for -1, 0 because 0th element is getting included. Of course, since -1 is there, I'll return a 0 from here, but this is the including call. This means that I will add 1. So 0 versus 1, I will return basically 1 from here. I will return a 1, right? I hope it is getting clear that why are we considering, right, this next element and my own element. I hope the recursion tree is kind of clear to everybody, that what is the meaning of when we can get included, when we cannot get included, right? And yeah, this is pretty much it. And overlapping sub problems will also lie in there only. So yeah, this is pretty much the recursion tree of this whole problem. I hope it is clear to everybody. Let's try to write the recursion pseudocode, right? I'll quickly summarize the recursion as well, because longest increasing subsequence recursion is a little bit tricky and it is not the optimal approach. We are going to discuss two more approaches to solve this problem. It is of course more confusing, it is like less optimal, more confusing and less optimal. So don't worry, if it is like still not clear, you can of course repeat watching the video, and I'll just summarize this quickly, and you can of course watch the more optimal things, and they are very easy to understand. So what we are doing at any point, I'll consider a next element, the element who is going to come after me, and I am on index idx, right? If the idxth element gets excluded, it will ask from all the previous elements, but the next element will stay the whatever same what was passed to me only, right? This will stay the same. Now there is an option. For example, if the element we are standing on, for example, is 5, and the next element, for example, the element we are standing on is less than 200, and the next element, next index is 5. Here, can 200 stand behind 5? Like 5th index, can 200 stand behind 101? No. So I will not do an inclusion call. So when will I do an inclusion call? I will only do an inclusion call if ARR of IDX is less than ARR of next. If this is the case, I will only do the inclusion call, and in the inclusion call, I will pass index -1. And since I am getting included, I will become the next index. In the end, I will return the max of including, excluding. And I hope this recursion code is clear to everybody, right? I'm not, emphasizing a lot on recursion, right? We have not explored this part of the tree as well. So don't worry, because, this recursion approach is very bad, like in time complexity wise as well. Of course, you can see we are having two choices at every point, right? And in the worst case, the time complexity will be 2^n, because n will be the depth of the tree, and two calls we are making. This is a small trick I've told you to tell what is the time complexity of any recursive code, right? So it is not very optimal solution, and I am agreeing with you all that it is not a very easy solution as well. Don't worry, we're going to cover more easy solutions for this, and this is not the only solution for this problem. But yeah, this you should also know, and it will actually make you understand this topic more, right? So let us write the recursive code and convert it to memoization quickly. So let us start writing the recursive code itself. So public integer, I'll consider integer recursion. Integer array nums should be passed. Integer IDs should be passed on which I'm standing on, and integer array. You can say what can I say? You can of course say integer array, not integer array. Sorry, integer next index, like the person index to the next person who's coming, right? What is the base case? If index becomes less than 0, I'll return -1. Oh, sorry, I'll return 0, right? I can always make an excluding call. I can always get excluded, right? So int excluding call is equal to recur for nums, idx -1, and next I'll pass as it is. Int included is equal to 0. I will, populate this variable included only if I can get included. So when can I get included? If the next person is equal to nums.length. Essentially, I'm saying that if it is pointing to infinite, that's the extra thing I took in the explanation. If that is pointing to infinite, or like next is equal to nums.length means that there is no next person than me. Then of course I can get included. Or if there is a next person after me, ARR of IDX, I should be smaller than that person, right? I should not write ARR here. I should write nums here. The person standing on this particular index, my index should be smaller than the person on next index. Then only I can get included. Include is equal to recur for nums comma IDX minus 1 and this index, because I'm getting included, I will become the next person. I will do a plus 1 because whatever the people who are able to, the people before me are able to make an answer, I'll add 1 to it because I am now standing in front of all them. I'll return math.max of including include comma exclude. I hope this is clear to everybody. In the end, I will return a recur and I'll pass nums here. I'll integer n is equal to nums.length. I'll start from the last index n minus 1 and for of course initially I'll say that for example there is no one in front of you, so what will you be able to do, right? So I hope the recursive code is kind of clear to you. We'll write the memoization. We'll not focus on a lot, you can say a lot of tabulation in this particular video, because tabulation for this code, now of course it will not get submitted, it will give me TLE. Let's quickly optimize it. Basically I don't want to discuss any tabulation in this particular video, because tabulation code we are going to do with a trick which will not only optimize the time complexity, but it will also optimize the space complexity as well, right? So but of course memoization solution, right? And here like basically I have to take a DP will be of 2 dimensions because index and next, you can see they are the variables which are getting changed. DP is equal to new integer. I'll say n plus 1 comma n plus 1. Let's make a DP of n plus 1 comma n plus 1 to avoid any out of bounds, right? So I'll pass the DP array here. Correct. I'll name wherever I've written recur, I'll name it memoization. Yeah. These are the small tricks I've shared with everybody. You can simply convert. I have shared the trick to convert recursion to memoization simply, memoization to tabulation simply, and then of course space optimization according to the problem itself, right? But yeah, these are the tricks we have discussed in this series, and of course if DP is getting easier for you, just tell me in the comments using these tricks itself. So DP we have created here. I'll pass here you can say DP here. Wherever I'm calling memo, I'll pass DP, right? Wherever I'm calling a memo, I'll pass DP. I'll pass DP here as well. And recall and remember. So if DP of IDX comma next is not equal to 0, this means that it has been touched earlier. I will return DP of IDX comma next. Correct. Okay. And remember, what is recall and remember? I will remember the answer here if I have not already calculated the answer. I will remember it in the DP itself. I hope this strategy of remember and recalling is clear to everybody. I'll pass a memo here and let us try to run this code now and let us see if it is working or not. I hope that code is correct. Yes, let's try to submit this code. And yeah, this is the recursion and memoization. Of course, in the next video itself, right, I'll be showing the tabulation approach for this video. But don't worry, recursive approach I've just shown in order to follow the paradigm of discussing the recursion and memoization for every question, right? But the main thing we are going to see in this problem is next video will be containing the tabulation of this concept, and next video, right, you can say will be consisting of the optimal solution to longest decreasing subsequence, right? And my friend, longest decreasing subsequence is a very important topic in all, right? You cannot the problems we are going to do next after discussing these 3 videos of longest decreasing subsequence only. You'll see that what is the benefit of learning longest decreasing subsequence, right? So I hope this topic is clear to everybody, that what do we mean by longest decreasing subsequence. I hope recursion is somewhat clear to you all, right? And in the next video we are going to see the tabulation of this. And yeah, I hope you are enjoying the content which is getting out there. So please share this with your friends. Try to post on your socials about this content if possible. Just try to spread the word that yes, DP is getting easy. So please I would be really thankful if you do that. And of course like and of course subscribe to the channel. I hope you are enjoying the videos, and until the next video, bye.